Hello, math scholars. Mrs. Harp here, coming at you with another math lesson. It's 8.7 factoring special products today. So just a reminder, you should be taking notes in your notebook and following along. If I get going too fast, just click pause and catch yourself up. Rewind a little bit if you have to and click play. So hopefully you get through this. At the end, you're going to have an 8.7 Polaris lesson. And you might even have an 8.7 worksheet on the back of an old worksheet, 8.6 day 3. If you still have that and you want to do it just for fun, you can turn it into me for bonus points. All right? But your actual assignment will be in Polaris today. So we're going to start ourselves off by just foiling out a few of these special cases. We have seen them before back, I think, in section 8.3. We're just going to remind ourselves what happens when we foil these. So we're going to do y plus 4 with y minus 4. Notice the contents of both binomials are the same, except one has a plus and one has a minus. So when we draw our first rainbow, we would do y times y. My board's not perfectly aligned, but y times y would be y squared. When we would do our outside rainbow, we would get a negative 4y. Our inside rainbow would give us a positive 4y. And our last rainbow would give us a negative 6. And at this point, we normally combine our middle two terms and get a trinomial as our answer. But when we combine our middle two terms, we have a negative 4y and a positive 4y. They actually go away, and our answer is a binomial. That's good to know. Because if ever asked to factor a binomial, and you see a bunch of perfect squares, it'll probably factor into two binomials with one plus and one minus with the same contents in both. That's where we're headed. Okay, let's do one more foiling problem. We're going to FOIL out 5m plus 6 with 5m minus 6. (5m) times 5m would be 25m squared. 5m times negative 6 would be negative 30m. A 6 times a 5m would be a positive 30m. And then a positive 6 with a negative 6 would be a negative 36. Again, our centers are definitely going to add up to 0, negative 30 and positive 30. So our final answer is 25m squared. Notice 25 is a perfect square, minus 36. So before we go any further, I'm going to take a second and describe to you what I mean by a perfect square and just list out a few perfect squares. They start looking familiar to you. So a perfect square is a positive integer that just happens to have another integer as its square root. So like, for example, 9. If I would square root 9, I'd get a nice happy answer of 3. There's no yucky decimals, it's just a whole number. So I'll go ahead and make a list of, I don't know, the first 12 perfect squares or so. So 1 squared would equal 1, 2 squared would equal 4, 3 times 3 is 9, 4 times 4 is 16, 5 squared, 6 squared, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, and 13 times 13. That's about the extent of what you should have memorized and be able to just look at and recognize as, oh, that's a perfect square. Because these numbers are going to pop up on pretty much every single problem we're going to factor today. So it's good if you recognize them at first sight. These are called perfect squares. You can pause the video and write all those down if you would like. So here's where we're headed with this. We are going to be factoring differences of two squares patterns. So basically what you'll have is two perfect squares with a subtraction sign in the middle, and you'll be able to use square roots to help you factor. So the pattern is a squared minus b squared equals a plus b in one binomial and a minus b in the other binomial. So it's up to you if you want to write that down or if you just want to do the first example problem with me. If you do want to write it down, you can pause the video and jot it down. If not, go ahead and try this first sample problem with me. So right off the bat, I recognize the 4 and 9 as numbers from my perfect square list. So to figure out how I would factor this, I would actually square root both of these terms. 4x squared, the square root of it, is just 2x. And I would fill both binomials with a 2x in the first slot. Then I would square root the 9, just the normal positive 9. If you try to square root a negative 9 in the calculator, it will give you an error because you can't square root negative numbers. So the square root of a positive 9 is 3. So I put a 3 in my both binomials in the last slot. Now one binomial needs a plus and one binomial needs a minus for all this to work out. And that's your answer. Since this is our first in the day, I definitely want to check it and just show you how it works, how the middles add to 0. But let's go ahead and FOIL it. 2x times 2x would give me that 4x squared. 2x times negative 3 would give me a negative 6x. 3 times 2x is a positive 6x. And 3 times negative 3 is a negative 9. So that kind of just proves that, yes, indeed, this would FOIL out correctly and give us what we started with. So we factored it correctly. All right? Well, good job. Let's go ahead and try another one. It says, don't forget to check for greatest common factors before you do the math problem. So if there's a 2 or a 3 or even a 5 you can divide out front, you'd want to do that. Unfortunately, I don't believe the 25 and the 144 have anything in common. I recognize them right off the bat from my perfect square list. So I think we definitely have the difference of squares pattern here. We're going to go ahead and square root both of those terms. The square root of 25p squared would be 5p. I put that in my first slot. The square root of 144 would be 12. So put that in my last slot. 1 plus, 1 minus, and I'm good to go. You can definitely check it if you want by FOILing out the answer we got. All right. Go ahead and write down 4b squared minus 100. I definitely recognize the 4 and the 100 from my perfect square list. I could probably just go ahead and do that square root trick. But there's a common monomial just bothering me a little bit that we're going to pull out first, okay? 4 and 100 definitely have a 4 in common we can pull out. And that's going to leave the stuff we're working with to be a bit smaller of a number. Okay? I'm left with b squared minus 25 in my group. I definitely can still do my sum and difference trick though. The square root of b squared is b, and the square root of 25 is 5. Just make sure you have 1 plus and 1 minus. That's your final. We're kind of going a different way with things. These are no longer difference of perfect squares, but there is still going to be some perfect squares involved in the problem that we do. So it says, don't forget to check for greatest common factor or greatest common monomial. 9 and 24 are divisible by 3, but I don't think 16 is. So unfortunately, there's no common monomial. We are going to head to the box method, and we're doing the box method because of that leading coefficient of 9. We cannot use old-fashioned method. So let's go ahead and draw ourselves our box and put a 9c squared in the upper left box. We're going to put a 16 in our lower right box, and I'll give you a second now to get your calculators out because these numbers will start getting a little big. And we'll multiply the 9 and the 16 together to get my number that goes in my circle. And it's 144. Oh my gosh, you should recognize him, huh? 144 is a perfect square. In fact, the square root of 144 is 12. So 12 times 12 is 144. And you know what? 12 plus 12 is 24. So that is exactly what we want to go with for the remaining 2 boxes in our square. 12c and 12c. Here's where this problem is going to get very unique. When you pull out your common factors in your top row, you will get 3c. when you pull out your common factors in your bottom row, you will get 4. Now, as I work this Punnett square around, 3c times 3c will give me 9c squared. And 3c times 4 will give me that 12c. So what's awesome is we get the same thing on the top as we get on the side, 3c plus 4. So you can leave your answer how I just wrote it here in blue, or if you want to be a super math scholar, I know a lot of you do, you can write 3c plus 4 squared, because we have the same binomial being multiplied by itself twice. Okay? So that's the more better answer. Give it a smile face. Okay. Alrighty. Looks like we only have one more to go. Awesome. So as soon as I saw the negative out front on this one, I was like, ooh, bad news. Whenever you have a negative, you would want to divide out a negative just so you could be working with positives when you're heading to your box method or your old-fashioned method or whatever method you're using. So instead of dividing out a -1, though, I'm thinking we could probably divide out a -2. Let's see what we would be left with. -18 divided by -2 would be a +9, a squared. -12a divided by -2 would be a +6a. And then -2 divided by -2 would be a +1. This stuff here in the parentheses is the stuff that we are going to do the box method with. So let's go ahead and draw ourselves a box. Make sure I hit this button and see everything in one problem. All right. 9a squared goes in your upper left box. Hey, I'm going to pause right now and give you the key word of the lesson. The key word of the lesson is trumpet with a lowercase t. Don't tell any of your friends because that's going to be a question on the homework and you don't want to give answers away, okay? The key word is trumpet. Thanks for watching the whole video, not fast forwarding. All right, the 1 is in the lower right corner. Multiply together to get 9 and put that number in your box. Alright, so when I'm brainstorming ways to multiply to get 9 and add to 6, definitely 3 and 3 come to mind. So it's going to be 3a and 3a. It's going to be the same case as on the last one, where we pull out the same thing in the first row as we do in the first column. We pull out the same number in that second row as we do in the second column. So when we go to write our final answer, there's one thing we don't want to forget about, and sometimes I'm guilty of forgetting about this guy. It's that -2, way back in the beginning. You need to have him out front. So you can write your answer like I'm writing it now, or you can be a super scholar and write the -2 with a 3a plus 1 squared. That's totally up to you. I would accept either. All right, thanks for watching the whole entire video. I hope you had a good time. This will allow us to catch up because of the day we missed with the snow day. The homework is in Polaris. It's just going to be 10 questions. Some multiple choice, some fill in the blank. So just try your best at that. And I will see you tomorrow.